So we ran out of time yesterday to do example 2, so that's what we're going to do right now. Let's draw a triangle. Let me get all this. There we go. So it kind of looks like an obtuse triangle. Doesn't have to, but this particular one does. Oops. Let's make it look like this. And make it come down here like this. All right, this is the triangle that is example 2. They give you, this is ABC, A, B, C. They tell you this is 15. They tell you this is 7. They tell you this is 9. Okay? Could we use the law of sines to solve for the angles here? No, you can't. Because you need 3 out of the 4, which means you need at the very least, one angle, correct? To be able to do the law of sines. Do you even have one angle here? No, you don't. So you can use the law of cosines with this. All right? So let's solve for angle. Well, they solve for angle A. So let's do that one. It doesn't matter. You could find B or C, but we're just going to do it like the example does it. They decided they want to find angle A. So let's find angle A. So do you remember the law of cosines? So it would be A squared, right? Because we're trying to find angle A, so we're going to use side A because it's going to have angle A in it. Then you take the other two sides. What are the other two sides? B squared plus C squared. It looks, at the beginning of it, it looks just like the what? The Pythagorean theorem, doesn't it? But then we add a little bit more stuff to it, all right? And we went through yesterday why we get to it. So it's minus 2 what? BC, because it's always this one and this one that goes with it. Everybody got it? So whatever these two are, that's what that's going to be right there. And then it's the cosine of the angle that's opposite this side over here. So what angle is it? Angle A. So that's what we're solving for. We're solving for angle A. Now, plugging the stuff in is not that hard. It's the solving for angle A that's a little bit difficult. Okay, so this is what we wanted to do yesterday, and we just ran out of time. So let's plug some numbers in on what we know. I'll tell you what, let's fill in the letters, though, so we know what's what. So what would we call 15? Is that A, B, or C? It's A. Why is it A? Is it just randomly A? No, because it's across from what? Angle A. Everybody got that? So that's pretty important. What would the 7 be? C, because it's across from angle C. And then 9 would be what? B. Everybody okay with that? Really, the only one that's important to know is the A, right? Because the B and the C, it doesn't matter which one's which, but the A definitely matters that it's the 15. So what am I going to do? Plug and chug, right? 15 squared equals B, which is 9 squared, plus the other one, which is 7 squared, minus 2 times 9 times 7 times the cosine of what? No, the cosine of A. A is the angle, okay? The capital A is the angle. We already used the lowercase a, which is the side, right? We already used the 15 over here. Everybody got that? So now what we're trying to do is we are trying to solve for angle A. This is where it gets a little bit tricky. So pay attention. Let's scooch this up a little bit. Give me some room. So this is what we're trying to solve for. So it's basic algebra. It really is. It just looks a little bit weird, all right? So what's the first thing? If that's what we're trying to solve for, we want to get rid of all this stuff over here and move it to the left side. So what's the first thing we're going to get rid of here? What if I had this? What if I had, I'm just making this up, 5 equals 2 plus, well, let's not do that. Let's 2 minus 3x. What if I wanted to solve for x? What's the first thing I would get rid of if I wanted to get x by itself over here? The 2. That's right. Because you get rid of what's being added or subtracted first. Everybody got that? Okay, so let's go over here. Look at this. It's basically the same thing. This is just a simplified version of this. Okay, so I want to solve for A, so I got to get rid of something over here. What am I going to get rid of first? What's being added or subtracted? What is being added to this A? What's being added or subtracted? The negative 2? That's not being subtracted. That's being multiplied. 2 times 9. And the 9 is being multiplied by the 2 and the 7. The 7 is being multiplied. And it's all being multiplied by the cosine of A. So I'm not getting rid of this stuff because what is this stuff doing? It's multiplying. So what do I get rid of? I get rid of what's being added or subtracted. So there's nothing being really subtracted. I'm going to get rid of the 9 squared. And I'm going to get rid of the 7 squared. So how do I get rid of a 9 squared? Minus 9 squared. Very good. You got it. Okay, minus 9 squared. And I'm going to get rid of the 7 squared by subtracting a 7 squared. Now, you may be tempted to put an 81 right there and a 49 right there. That would be okay. It wouldn't be wrong. But what I'm going to do, I'm going to try to put everything in the calculator all at once. Okay? So watch what I'm going to do. I'm going to take that 15 squared, and what am I going to do to it? What am I going to do? I got to get rid of that 9 squared, so I subtract a 9 squared. I'm kind of skipping a step. I'm not putting minus 9 squared cancel out. I know it's going to cancel out when I subtract it. Would you agree? So if I subtract a 9 squared, it's going to go away. How do I get rid of that 7 squared? Do the same thing. Subtract a 7 squared. You with me? And I do it to the other side, right? That's why I did it to this 15 squared. Whatever you do to one side, do to the other side. So basically, all I did was this. Do you agree? Yeah, that's basically all I did. Okay? Equals. I could do the next step in my head, but I'll just write it all down. Just save you a little confusion. Okay, so what did I do here? Right here, the simplified version, how do I get rid of this negative 3? It's being multiplied, isn't it? So how do I get rid of something that's being multiplied? Divide. So I divide by what? Negative 3. This is kind of the same thing. It's a little harder, I'll admit. Okay, it's kind of the same thing, but all this stuff is being multiplied by the cosine of A. I'm not going to mess with the cosine just yet, okay? So how do I get rid of a negative 2, a 9, and a 7 if it's being multiplied? Divide. That's right. So I'm going to divide this whole side by what? Negative 2 times 9 times 7. Isn't that a little easier than going, 2 times 9 times 7 and getting the big old number? Yeah, I think so. So what's going to happen here? I divide, and then it cancels. So now, this will save me from writing all this again. So this is now equal to what? The cosine of A. We've only done 2 steps. We subtracted a couple things. We divided a few things, right? Was that difficult? No, I don't think so. And this is something that we've kind of done before. The cosine of A is equal to all this stuff. So if I wanted to get A by itself, do you remember how we get rid of the cosine? Take the inverse. That's very good. Take the inverse cosine. That'll cancel it out. So I take the inverse cosine of this. All right, so what's it going to look like? It's going to look like the inverse cosine of all this mess right here. Oops. That's what we're putting in the calculator. The steps weren't that bad. 3 steps. I subtracted 9 squared and 7 squared. That was 1 step. The second step, I divided by a negative 2, a 9, and a 7. That was my second step. The third step, I got A by itself by just taking the inverse cosine of it. Say it like that, it's not so bad, is it? Okay? And you're like, how in the world am I going to put that in a calculator? Well, you could do it by bits and pieces if you wanted to. Okay, you could figure out what that number is, write it down. Figure out what that number is, write it down. Put them back in your calculator, and then hit the second function cosine, and you should get an answer for A, and you should get 139 degrees, or approximately. Probably comes out to a decimal, and it rounds to 139. You want to see it done on a calculator? And I think when I record this, it's not going to... Oh, yeah, it is over there. Good. All right, so let's do it in a calculator that looks like this. All right, so first thing I'm going to do... Oh, that's the first thing I'm going to do. That's right. And I always forgot. Thanks for reminding me. Years ago when I used to use this calculator, I didn't have to do this every single time. There we go. All right, clear. Where's the clear? Right there. All right, now we're in degrees. So first thing I would do is I would hit second function cosine. All right, already puts a parentheses right there. And let's just put the numbers in. So here we go. 15 squared minus 9 squared minus 7 squared minus 7 squared divided by negative 2. So put a negative 2 times 9 times 7. I'm going to close that parentheses, right? Because we got to close parentheses right here. And now I should be ready to get an answer. And of course it doesn't work. Figures. Where's my clear again? There it is. What did I do? 15 squared. Inverse cosine. 15 squared minus 9 squared minus 7 squared divided by negative 2 times 9 times 7. No, I think it's a parentheses issue.
We could put 2 parentheses.
I don't know. This should be right. Well, you know what? I should have put this thing in parentheses. That 15 squared. Okay. Can I slide it in here now? I don't know. I don't use this calculator too much. It doesn't look like it's letting you move it around. Let's try it again. Let's clear the whole thing. So that's what it is. You know what it's doing? It's doing this. It's going negative 7 squared divided by negative 2. See, it's not doing all this and then dividing that whole thing by negative 2 times 9 times 7. So I need to put that 15 squared minus 9 squared minus 7 squared in its own parentheses. All right, and I was thinking about doing that, and I should have. But, you know, you live and learn. Let's try one more time. You ready? Now, if you just have a regular scientific calculator, you're going to do it a little bit differently. Okay, so what I would do is I'd go 15 squared minus 9 squared minus 7 squared, hit equals, divide it by, then put a parentheses, negative 2 times 9 times 7, close the parentheses, hit equals. That'll give you this whole thing. Then you would hit second function cosine, and then you should get 139. Is anybody trying this? Okay. So let's try this one more time with this calculator. I just got to put the parentheses in there. Is that what you did? Yeah. So let's put another parentheses, right? So now I'm going to put 15 squared. It takes so long moving my finger along this mouse pad to minus 9 squared. Oh, this one. Minus 7 squared minus 7 squared. Close that parentheses right there. So that's what's important right there. Now you can hit divide. I'm pretty sure. I know what. I'm just going to be safe, and I'm going to put this in parentheses as well. The negative 2 times 9 times 7. So I'll close that parentheses. That closes the bottom. This one closes the whole entire thing, and I hope it works. Yay, it works. 138.9, lots of parentheses, okay? But again, if you wanted to do this, look, if you wanted to just do that, stick a number right there, then do this, stick a number right there, take those two numbers, divide them, then hit second function cosine. That'll work, okay? Yeah, however you want to do it. But just make sure that you know how to do it, okay? Everybody with me on that? All right, let's get rid of this. All right. And let's just finish up the rest of this. And when's this class over? 10 till? Yep, 10 till. All right. So what else we got over here? Let's get rid of this mess. We don't need this anymore, do we? Let's change this to a different color just so it kind of stands out a little bit. So what did we say we got? We got 139. Yeah, so this is 139. So now we got to solve for B or C. Doesn't make any difference. I'm just going to do what I did. I solve for B. But now look what you have. You have an angle and you have a side opposite that angle, and you have this side B. So now we could use what? Law of sines. So now let's use the law of sines to solve for angle B. So I'm going to put that on top, since I'm solving for an angle, over side B. What's side B? 9 equals. Now, what are the two that I know? I just figured out what A is, so now I'm going to actually use it. So the sine of A over side A. What's side A? 15. Law of sines is looking pretty easy now, isn't it? Well, if you've practiced it, it is. If you haven't, it probably looks as hard as when I first went over it. So let's get rid of the 9 first. How do we get rid of the 9? It's being divided, so we multiply by 9. I'm going to put that right there. And then, if I want to get B by itself, we kind of talked about that already. I got to get rid of that sign. How do I get rid of the sign? I take the inverse of the sign. Okay? Copy, paste. I accidentally grab the equals. Don't need that. There we go. So that's what you're sticking in your calculator. So angle B, if you put it in, is approximately 23 degrees. It says to round it to the nearest degree, so that's why we keep it 23 degrees. We don't make it a decimal. So that wasn't too bad at all. Angle C should be pretty easy now. So angle B was 23 degrees. I know this is 139. Now it's simple math. And I'm not just saying that, right? It really is. So what's my math? 180 minus 139 minus 23. And that's going to give you 18. So angle C is 18 degrees. And that's it. That's how you solve the triangle. Definitely the hardest part was just getting A by itself with the law of cosines. But if you do it a few times, it's really not so bad. We okay with that? Did it make any sense? Am I explaining it okay? Again, it's just 3 steps. Subtract these 2 things, divide these 3 things, take the inverse cosine, throw it in a calculator, if you want to count that as a 4th step, I guess. But bang, you got it right there. Then the rest shouldn't be too bad. Use law of sines. That's not so bad now. And then that third angle, that's really pretty easy. Are we good? All right. I'll take your word for it. Tell you what, I'll give you the rest of the time. We got 10 minutes. I don't usually give you a whole lot of time to work on stuff in class, but I'll let you work on 13.5. Okay, if you were confused on some of them, maybe this helped you out. Okay, if you needed to solve for A itself, that's actually a little bit easier. You just chuck the stuff in and just make sure that you put in the calculator correctly. But that's how you do the law of cosines. No more questions? All right.